Hi guys, so we're going to be writing the Nodal equation for this particular circuit. I know the circuit looks a bit complicated, but it's actually really easy. So first we're going to use KCL because Nodal equations use KCL. KCL is basically the sum of currents going to a particular node to be equals to the sum of currents leaving that particular node. And I'm going to be representing currents with V higher minus V lower over the resistor that the current is passing. This is your basic Ohm's law actually. Next, first we have to identify our nodes. So in this case, you may potentially say this is a node, 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 this is a node. I remember I did this first when I saw this question. So yes, this is a node, but notice how this is just a wire. There's no distinct elements there to say that this node is different from this node. There's no element dropping voltage or current or whatever. What is here is the same thing as what is here. So this entire node is actually the same thing, V1. This node is a very distinct node. You can see there's an element here, there's an element here. So this node is very different from this node. This is another node V2, and this is our third node. But again, this is just a wire. So you can connect all these nodes together. And this will be your what? Your V3. Now we're going to do KCL at each node. So at node V1, the current entry is simply going to come in like this. And it's going to pass in three ways. It's going to pass here, at this position, and at this branch. So the current entering is 15 volts minus V1 over 20. Let me explain. The voltage across this 20 ohms at this position is higher because this is literally a battery. And at this position, it is lower, it has dropped. So V higher, which is 15, minus V1, which is at this position, all over 20. Before I used to write 0 minus V1 because I was like, the current here is, since this is ground, V equals to 0. But because of this battery source, this will have 15. Now, the current leaving is this 5 ohms one. So it's going to be, what is the voltage across this 5 ohms? It's going to be V1 minus V2 all over 5. For the 10 ohms at this position, it's going to be what? V1 minus V3, because the node here is V1, the node here is V3, all over 10. And plus, this is just the current source itself, so you don't need to start writing the whole formula. It's just 3. Multiply through the equation with 20. You're simply going to get 15 minus V1 equals to 2V1 minus 2V3 plus 4V1 minus 4V2 plus 60. This is to this, this is to this. Simplify the equation, you get minus 7V1 plus 4V2 plus 2V3 equals to 45. So this is the first equation. Now at node V2, let's see what are the current entering and what are the current exiting. You see this current is entering at this position. I'm going to say that current is going to exit at this position and at this position. As this comes in, this will exit and this will exit. Now someone may actually say that since this is actually a current controlled voltage source, it means current is controlling, but this is actually a voltage source, that maybe current can be coming through this way. I won't say they're wrong. It's just you have to calculate everything properly. So, but this is what I choose to do. So in this case, the current entry is going to be what? V1 minus V2 over 5 equals to, what's the current exiting? Let's first start with the easier one. V2 minus V3 over 5. That's for this 5 ohms here. Now for this one is going to be what? V2 minus, because V2 starts here. Now this one will get a bit confusing. Minus, what is the sign you're seeing first? Plus. Plus 4 I naught, because this is a voltage source. It's just current controlled. You can go on and check what that means. Over 5. So that's the formula. And we know what I naught is because everything has VVV. This I naught is such a weird thing to have here. So I naught is equals to, look at I naught at this position. I naught is equals to, at that position, what's the voltage? V1 minus V3 all over 10. And so therefore, for I naught to be what? 2 over 5 V1 minus V3. 4 over 10 basically gives you 2 over 5. Now substitute back in the equation. You have let's also multiply 3 by 5, so you can just easily simplify this equation. V1 minus V2 equals to V2 minus V3 plus V2 minus 2 over 5 V1 plus 2 over 5 V3 if you multiply this in. And in case you're confused, what I just did was I substituted this into here. So minus times minus 2 over 5 times this, minus 2 over 5 times minus V3. That's what gives plus 2 over 5 over V3. 2 over 5 V3. Now just simplify the equation. You can multiply through with 5 again, just so you can cancel out this bottom 5 here. So it will be 5V1 minus 5V2 equals to 5V2 plus 5V3 plus 5V2 minus 2V1 plus 2V3. Simplify this entire equation. You're going to have 7V1 minus 15V2 plus 3V3 equals to 0. That's just it. And now at V3, that's at this third one, what's coming in? Current is coming in. There's a current that was coming here. It also enter into the node. Current is also here. It enter into this V3 node. This current is also coming in. And lastly, everything will exit at this point. So at node 3, what is entering? V1 minus V3 over 10. That is the center one that was 10 for 10 ohms plus the 3 amps plus the one for the 5 ohms, which is V2 minus V3 over 5 equals to. Now this one that comes at this position is a bit tricky. So it's going to be V3, which is the node, the V higher, before voltage drops across the 50 ohms resistor, minus, so V higher minus. Then simply take the sign you first see here. So it's going to be V3 minus 10. V3 minus the normal one, then minus 10 because the sign was minus all over 15 ohms. So just simplify this, multiply through by 30, and if you evaluate, you're going to get 3V1 minus 3V2 plus 6V2 minus 6V3 plus 19 equals to 2V3 plus 20. Simplify to V1 plus 6V2 minus 11V3 equals to minus 70. This is our third equation actually. This was our second equation, and this was our first equation. Solve this as simultaneous equations. I feel like we can all do that. You're simply going to get that V1 is equals to minus 7.1918 volts, V2 is equals to minus 2.779 volts, and V3 is equals to 2.886 volts. So these are your final answers. But you can stop at just making another equation. Thank you for listening.